Welcome to the Nursing Post podcast, All Nursing All the Time with Ashley Moore and Rosa Horsley. In this episode, we discuss stem cells. Our goal is always to inform, help, and start conversation.
Stem cells are the foundation cells for all organs and tissues. Stem cells are a single cell that can replicate or become specialized cells. It's almost like a blank slate. But to better understand stem cells, we kind of got to go back to our last podcast, or this really kind of ties back to that with the in vitro fertilization.
Yeah. From our last podcast, you'll remember that we talked a little bit about IVF, and you'll remember that in the lab, they take embryos, your eggs, and then they take some sperm, and then they put it in this nice dish, and then the sperm finds the egg, and then there we are, we're inseminated. Then the eggs and the sperm, they're stored together, and, fertilization happens, and then 3 to 5 days after that, you have an embryo that's ready to be implanted. But, in this case, we're not implanting.
Right.
A blastocyst is a pre-implanted embryo that develops 5 days after fertilizing the egg and the sperm.
Right.
So the embryonic stem cells are derived from that inner cell mass of that blastocyte. These are what's not, implanted. These are actually donated embryos that were not used during IVF. And there's actually signed informed consent if you choose to donate your embryos. Let's say you've had successful implantation, you have your 2.5 kids, and
you're happy.
You're happy. So
you don't need those embryos anymore.
You've pretty much donated them to that facility or to research.
Which later on we talk a little bit about why there's such a big ethical debate about these donating and what to do with these embryos. Another place we can get stem cells from are actually adult stem cells. They are hidden deep within organs, and of course they're surrounded by millions of other cells. You can see why that's a little bit more difficult.
Yes.
And we think that they may help replenish the body cells when needed. We know that we constantly have cells that are dying and being regenerated. We're thinking those are from stem cells.
Skin cells, they regenerate, hair
all
cells.
The time.
Yeah, all the time.
Unlike embryonic stem cells, they are already somewhat specialized, and experts have been able to look at blood stem cells and isolate them in adult mice, and they've then been able to have them produce liver, muscle, or skin cells. So it's almost like the adult blood cells are almost a blank slate, but they haven't been able to replicate this in humans, just mice.
Yes, just mice. I remember seeing a picture back in the day of an ear in a petri dish. Do you remember that?
I do remember that. It's freaky.
It is freaky, but that's pretty much what they're doing.
That's exactly what they're doing. And the thought of this is that they'll use adult stem cells to treat conditions that are caused from organ degeneration. If we can put stem cells there that can regenerate and help like a heart or a liver
or a lung,
then all of a sudden the problems from the body not being able to fix it are
fixed. IPS, induced pluripotent stem cells, are adult cells altered to have the properties of embryonic stem cells. That's why they call them IPS. These adult cells are reprogrammed to behave like embryo stem cells, but they're not the same. No. These cells were created by using viruses. And what they do is they insert extra copies, like 3 or 4, and that's kind of important in making embryonic stem cells turn into the specialized cells. I guess the big taboo about this is that they're using retroviruses, and they're using them for transcription factors. Research is currently trying to make a safer way for engineers and people that are researching IPS cells to use a safer method than viruses.
Right.
Because you can imagine, as we've seen in all the movies, where it might accidentally
change the wrong thing. And then what do you end up with?
Yeah.
Do you really want to trust a virus to make the proper change every time? I mean, from what I know, viruses mutate. That's what they're known for.
Absolutely.
Hello.
Look at the flu. Yeah, like look at the flu. We get vaccinated every year because the strains keep changing and they keep mutating. That's a fear of mine. But then another fear is, what if it accidentally gets out of the lab? How do you control it then?
And then another stem cell is the multipotent stem cells. And these are new stem cells. They're like self-renewing that become specialized or differentiated cells that have more specific functions, like blood cells, brain cells, heart, muscle, bone. No other cells in the body have the natural ability to generate new cell types. Cells are what they are. They don't
from
just
wherever
change.
you got them.
Right.
Exactly.
Blood stem cells, umbilical cord blood, and prenatal stem cells are the big ones that we know about.
Mm-hmm.
Stem cell transplant, also known as bone marrow transplant, which I know people are probably much more familiar with a bone marrow transplant.
Mm-hmm.
In stem cell transplants, they replace the damaged cells, damaged by chemotherapy or disease, with cells from another person that is healthy to fight against cancers like leukemia, lymphoma, neuroblastoma, or multiple myeloma.
Mm-hmm.
So really this is stem cells, particularly right now, are only used in medicine for
cancer treatments right now.
Cancer treatments in this capacity.
Yes. Mm-hmm. So, stem cell treatments and research. Currently, all forms of stem cell research in the U.S. are legal at the federal level. Mm-hmm. However, the use of federal funds for human embryonic stem cell research is restricted, and state and privately funded research is still open. So the testing that we're doing on these embryonic stem cells, they're not coming right now from the federal government. They're coming from private individual labs and state-owned labs. Right. So the CDC, I guess, which is a government entity, is not researching embryonic stem cells.
Right. And I think that this law went into effect in the early 2000s under the Bush administration is when he said, no, we're not doing this anymore. So if there's stem cells from the 90s, those can be used. It's just not
any new donations. Absolutely.
Unless it's being paid for
by a state or privately funded lab.
Right.
Yeah. So currently the only stem cell treatments approved by the FDA are products that treat certain cancers and disorders of the blood and immune system, which was what you were talking about before with the bone marrow transplants and, cancer treatments. In 2019, the donor registry consists of more than 22 million potential donors.
It's a lot.
That's a lot of eggs out there.
Mm-hmm. More
than 300,000 cord blood units are on the donor registry. That's a lot too. Mm-hmm. That's a lot too. This total includes nearly 97,000 units from the National Cord Blood Inventory, with nearly 4,000 NCBI units that were added in 2019.
Which, in my opinion, instead of destroying the embryos that are at these fertility clinics, if you're not keeping your kids' cord blood, then donate that. Let them research on that.
Absolutely. Yeah.
I thought that was a great alternative.
Yeah. So in 2018, 4,837 unrelated bone marrow and cord blood transplants were performed in the United States. Seeing with everything that's been donated, that number's pretty small.
Right.
That's not a lot.
No. I think we're just still in our infancy.
Yeah. I mean, we're still trying to research, and like we mentioned, there are some taboo issues.
Sure. Absolutely.
Surrounding this. People who might benefit from some stem cell therapies include those with a spinal cord injury, maybe type 1 diabetes, Parkinson's, Alzheimer's, heart disease, stroke, burn victims, cancer patients, people suffering with osteoarthritis. Stem cells have that potential to be grown and to become new tissue to be used in transplants and regenerating. Just imagine how on a burn victim, somebody who has 3rd, 4th degree burns, how regenerating skin cells
would be huge.
That's huge.
And would decrease infection. I mean, you have to think that's your body's first line of defense against infection is your skin.
Mm-hmm. Absolutely. It's kind of exciting.
It is exciting. There are 2 successful studies with mice, of course, with prostate and mammary glands being produced from a single stem cell. That's 1 cell. I mean, we know in our mind, these are really itty bitty, and you can get all these cells just from a drop of blood. So if you think about like a cord,
that's a lot.
Blood, that's a lot of different stuff that can be regenerated. Right now, of course, it's just these 2. The problem with stem cells that are generating organs is that we are manipulating them and they are making that specific tissue. But what happens is because we're manipulating them, it makes changes to the cell's mitochondria. We know is the powerhouse of the cell.
Yay! Biology!
Biology! And when the cell replicates, of course, that change is permanent. And there's risk of rejection from these organs because something's different, even if it's from the patient.
Yeah, even if it's your own stuff. Yeah, so your own blood.
That's where it kind of gets a little bit. I did find a really cool article from 2019, which I was happy that it was very recent.
Tell me about it.
I thought, I was like, ooh. There have been 2 successful cases of stem cell transplant in HIV patients. And so what does that mean? There are 2 patients. They were very similar. One was in 2019, and then one was about a decade before them. But they both had a form of blood cancer that wasn't responding to chemotherapy. And of course, if they were HIV positive, they had this virus on top of their cancer. They both required a bone marrow transplant, so their blood cells would be destroyed and they would be replenished with stem cells from a healthy donor. But instead of saying, hey, we're just going to find a suitable donor, Dr. Gupta, he's an infectious disease physician at the University of Cambridge, he specifically picked donors who had 2 copies of a mutation called CCR5, which is just a gene that is resistant to HIV infection. I say just a gene. It's a gene that is resistant to HIV. That's crazy. I didn't even know that there were genes that were resistant to HIV.
That Human Genome Project.
Right. And he took donors that had those 2 genes, and that's what he used for the stem cell transplant. And that patient is cured from HIV. They waited a year and his viral counts were non-existent. So they took him off antiviral medication, waited, and it's still gone. There's just nothing. And just for a little fun fact about this, 1% of European descendants have these 2 copies of that CCR5, that mutation that is resistant to HIV.
That's very interesting.
But just think about the scope of the world and HIV and AIDS.
Absolutely.
And we have isolated this gene that's resistant. Like back to designer babies.
And our upcoming episode.
This is amazing. Could you imagine being that person, like, they're obviously doing well with their cancer. But in addition to that, now their HIV is gone. And this is 2 different cases that were both successful. And 2 is, of course, a minuscule number. It's not even like a study.
But not to that patient who was told. Remember, back in the day when you were told you had HIV, it was pretty much a life sentence. Like, you knew at some point
this was going to turn to AIDS and I'm going to die.
Or something else was going to kill you, like pneumonia or the flu or something else.
Right.
So for these patients who probably were diagnosed and felt like this was a death sentence, they're pretty much cured.
Yes. So I thought that was awesome. I was very happy to find that study. And of course, it'll be in our show notes if you want to read the study yourself.
So there are currently over 1,200 ongoing studies. That's promising.
Yes.
We're going to transition into cord blood and whether it should be saved or donated.
It could save a lot of lives if you donate cord blood or you save cord blood for the future. I mean, in 50 years, who knows what scientists can do with it?
I have no idea. A lot, I know, because we're already doing a lot. But if you have a family history of a blood disorder or certain cancers, your baby's stem cells will be a close genetic match to his or her brother or sister or another family member. The blood may be helpful in future treatments. So if you want to help others, you can donate your baby's cord blood to a facility that provides life-saving stem cells to patients in need. You can store cord blood at a public or a private bank, and private cord blood banking costs between $1,400 to $2,300 for collecting, testing, and registering, plus $95 and $125 a year.
Right.
That's pretty. I thought it would be more than that, actually.
I did too. I was surprised that the numbers were that low because I thought that it would be something along the 14 to 23 a year. But that's just an upfront cost just to get it there, and then it's just chilling. And for less than $150 a year.
People pay more than that for storage units.
People pay more than that for coffee.
You're right. I didn't think about it that way. You're absolutely right. So the FDA posted a warning in 2019, and pretty much the U.S. FDA was concerned that some patients are seeking cures and remedies, and because they're at that point so desperate for a cure, they might be more vulnerable to manipulation and to fraud and for people taking advantage of them.
Right. Promising treatments that are not.
Cures to things that just aren't curable. And so the FDA has the authority to regulate stem cell products in the U.S. This is very important because if you're that patient and you're searching for that cure, the two most important things you need to be looking for is that your treatment has been FDA approved.
Right. And what that tells anybody is this has been studied. It is effective and safe.
That's a big deal.
Right.
Being studied under an investigative new drug application, which is a clinical investigation plan. These get submitted to the FDA. This is what allows, clinical trials to proceed.
Right.
And you want to make sure that whichever treatment that you're seeking, if it's not already FDA approved, has at least filed its application for this clinical trial that you're seeking treatment from.
Any reputable facility is going to have their approval by the FDA before they start clinical trials. There's a whole setup that has to be done. It's not just something that you just throw together and say, oh yeah, come on in, we're going to go ahead and do this. We'll get the FDA approval later.
Absolutely not. But unfortunately, there are some places who will try this.
A little shady.
Yes. So, as always, we're going to list our references in our show notes, and there is actually a list of FDA approved facilities on this website that are governed by the government, so you can look them up before you start researching your possible treatments.
Right.
And as part of the FDA's review, investigators now have to show each product will be manufactured so that the FDA can make appropriate steps and make sure the appropriate steps are being taken to help ensure the product safety, the patient safety, and that, they can replicate through the scientific process, that it works.
Right. Evidence-based data.
Absolutely. So researchers are currently using mice stem cells in research along with those human embryos that are donated.
Right. I would say that if you have embryos and you're not going to do anything with them, I would say at least donate them. So
absolutely.
In the trash.
Instead of destroying them, they might save somebody else's life. So absolutely. I'm all for it.
And a lot of people depending upon their religious belief, as soon as the egg and the sperm come together and make an embryo, they consider that a life, which is why this is so controversial. Is it a life?
That's been the topic of debate for, I think, as long as I can remember stem cells being around.
Right. And that's where everybody's like, well, what's the big deal? It's a stem cell. It's a cell. It's in a petri dish. It's not in the person. There's a lot of different views on that. But if you don't take the embryo and actually implant it, then it is going to be destroyed. And that is a potential
life that could have been saved.
Right.
Absolutely. I agree with that. This debate is not going to stop with us.
No.
It's not going to stop with our opinions. People have been arguing this concept of life at conception or life at birth. And I think it's going to continue to be around a lot longer than us.
Right. And I guess it all depends on how you look at it. If you had a baby in the traditional method, then you would have to go to a clinic and have that embryo removed via an abortion. It's just different because they did it in a petri dish versus in a typical fashion.
Mm-hmm.
There are risks involved with stem cells and what can be done. In 2016, the FDA had a public workshop that discussed several cases of adverse events. So this is something that you would have to watch out for. A patient came blind due to an injection of stem cells into the eye.
Ugh.
I'm not an eye person.
I'm not a needles person.
I can do the needles, it's just not an eyeball.
You see it coming.
Oh, I can't even.
You can't even turn your head.
Oh my goodness, no. Another patient received a spinal cord injection that caused the growth of a spinal tumor from stem cells. This is why it's so important that you make sure that you're at a facility who's reputable, that
regulated.
Exactly. A lot of these things come into play when it comes to stem cells. It's a very gray area.
It is a very gray area, but even oral medications are sometimes gray. You still have side effects.
Absolutely.
Just from regular medication. The FDA, their concern is you might have an allergic reaction or an adverse reaction, at your injection site.
Right.
That's plausible.
Hopefully not a growth of a tumor.
Yeah. Yeah.
That's a little much. Guess that stem cell was replicating.
Absolutely. The wrong gene may have been turned on.
Yep.
Failure of cells to work as expected, like Ashley said, with the growth of tumors. It's very important that you're doing your research in everything. Just make sure you're doing your research. And if you're one of these sites that is not FDA approved, I'm just letting you know right now that they may take, and they have already taken, a variety of administrative and judicial actions, including criminal enforcement and, violations.
So that's why it's important to do your research and know your stuff before you jump into anything, which is why we make sure that we do our research when we do these podcasts.
Yes, and we put them in our show notes with our references.
Yes. So, of course, we will link our references. You can find it on our website, www.thenursingpostpodcast.com. We would love for you guys to join in the conversation and leave your comments. Let us know what you guys think about embryos and if it's something that should be donated or what your feedback is on that. Of course, make sure that you subscribe to our podcast, and you can listen to us on your favorite podcast platform, and you can follow us on Facebook and Instagram. Thanks again for listening to The Nursing Post.